Hey, I'm Courtney Waterman, your tutor. Lover of anime, manga, and math. And you just tuned into another session of Tutor Me Sempai. Welcome back, everyone. Today we're jumping into our 7th grade topic, finding the area of a shaded region. Before we jump into our question for today, I will first lay out what steps are going to be necessary. However, if you want to skip ahead to our question, feel free to visit the time codes in the description box below. As always, if you have any questions about what you see here or even your own homework, feel free to put them in the comment box or visit me on Facebook at Tutor Me Sempai and tell me all about it there. When you find this video helpful, remember to leave a like, hit the notification bell, smash the subscribe button, and share this video with a friend. Without further ado, let's talk a little bit more about finding the area of a shaded region. Today I'm going to give you 5 really easy steps in order to find the area of your shaded region. Our first step is identify your outside shape. You have a shape, for example, let's say this shape here. If you had shapes inside, we want to know what is our outside shape. What is this overarching shape, this big shape on the outside? In this case, we have a rectangle. So that is going to be very important because we're going to need to find areas. And if you don't know what the shape is, then you don't know which area formula you should use. So identify your outside shape first. Your next step. Identify all of your inside shapes. So going back to your rectangle, if we had that square, circle, and triangle, we need to know what are the inside shapes. So we already talked about the outside being this rectangle. Well, the inside, we have to identify all of these shapes. That's going to be very important because once again, we have to find the area of everything. So we need to know which formulas we're going to have to use. So, second step, identify all of your inside shapes. Your third step, find the area of all your inside shapes. So going back to this previous example of a rectangle, and we had that square, that circle, and that triangle. If we want to find the area of all of our inside functions, we need to do the area of a square, we need to do the area of a circle, and we need to do the area of a triangle. So whatever those formulas are, we need to find those areas. That is our third step, finding the area of all of your inside shapes. It's important that you don't miss any of them. You have to find all of your areas. Your fourth step, you want to find the area of your outside shape. So in this example that we've been talking about, the rectangle was the outside shape. So find the area of your outside shape. So at this point in time, we've identified both the outside shape and all of our inside shapes, and we found the area of every shape that we're dealing with. The last step is the most crucial step. We have to subtract the sum of the inside areas from the outside area. So going back to this, if we find the area of our rectangle, we need to subtract the sum, so the area of our square plus the area of our circle plus the area of our triangle. We need to add up all of these and subtract it from the area of our outside shape, which was our rectangle. Here's some good information just to have while you're finding the area of these shaded regions. The first one, you don't necessarily have to have 1 or 2 or just 3 shapes inside. You can have 1 up to however many shapes can fit. As long as your outside shape can fit them all, they can be there. So don't think that you're just going to have 1, or you have to have 2, or you have to have 3. You can have 1 or many shapes inside your outside shape. The second bit of good information to have is that your inside shapes, or even your outside shapes, don't have to be regular shapes. So don't always expect a square and a circle inside, or a circle with a triangle inside. You can have irregular shapes inside or outside as well. If you have any difficulties finding the area of these irregular or complex shapes, no worries. I actually will link my video to my previous video on how to find the area of your complex shapes. So check that one out and see if that clears up any confusion you may have. Your third one, and this one is probably the most obvious. Don't forget your units. As you're finding these areas, sometimes it'll be in yards, meters, inches, whatever they are, you get really wrapped up in the math of it all. And your final answer may not have the units because you've lost them during the math. However, don't forget those units. You can lose valuable points if you don't put them on your test or your homework and your teacher's expecting them. So, don't forget your units. Remember to always tag them on at the end if you're not carrying them through during your math. In today's question of the day, we have these two irregular or complex shapes, and we need to find the area of this shaded region here. So our abbreviated steps say identify the outside, identify the insides, and this is talking about the shapes, your outside shape and your inside shapes. Then we're going to find the area of the insides and find the area of the outside. So find your areas of all your shapes, both inside and outside. Then our last step, subtract the sum of the insides from the outside. So that's talking about the sum of your inside areas, and it was subtracted from whatever the outside area is. So these are our abbreviated steps. So our first step says identify our outside shape. Now I don't really know what this is by looking at it, but we can identify this by determining what areas we're going to have to need. I break this up into some mini shapes. So this would be 1 and this would be 2. So this right here looks to be some sort of rectangle. So that's going to be the area of a rectangle. This here, our shape number 2, I don't know what that is by looking at it, but that's going to be the area of a parallelogram at the very least. I'm not sure if it's a square or a rectangle, but I'll say it's an area of a parallelogram. So the area of our rectangle is going to be length times width. And our area of a parallelogram is going to be base times height. So that's identifying our outside shapes. If we add both of these together, area of our parallelogram plus the area of our rectangle, we've identified what our outside shape is. Now let's move on to the inside. Step number 2. You see we're going to have to do something pretty similar. So if this is outside, this will be our inside. And I'm going to break it the same way. So we have area of a rectangle, area of a parallelogram, and we're going to add those two. And that's how we get our inside shape. And this was length times width, and this was base times height. So we identified both our inside and our outside shapes. Now we have to find the actual areas. So let's find the area of our rectangle. We know this is going to be length times width. And you see here that this length is about 18 meters. So we're going to say 18 here. And the width, since we broke out our rectangle this way, is going to be this 6. This is how wide it is here. So it's going to be 18 times 6. How about our parallelogram up top? Base times height. We might be able to find the base because this base is going to be the same as this top here. So we can say that's going to be 7. But what is our height? Well, if this total height here is 13, and we know that this height here is 6, well, if we cut off our bottom 6 from this 13, what's left? Well, that's 7, right? 7 is left. So we know that this shape here has a 7 for its height. So this actually looks like it's a square. So when we multiply all of this, we get 18 times 6 and 7 times 7 to be 108 and 49. And when we add both of these areas together, we get 157. And that is the area of our inside. So I'm going to write that down here. AI is 157. So now we found the area of our inside shape. We broke it apart because it was an irregular shape, and then we add all the pieces together to give us back what the area of our total shape is. The area of our total shape is 157 meters squared. So let's move on to step number 4. Find the area of our outside shape. And we're going to be doing the same exact steps. So I'm going to erase this inside because we have it here, but we're going to be doing the same exact steps. So looking at this area of a rectangle here, we know that the length is going to be this 36. But we don't know what the width is. We don't know what this is here. We do know that the total thing is 28 here, and we have this little piece of 11 that's broken out, so we can use both of those to find out what that width is. So what do we get when we have this total of 28 and we subtract this 11 here? What is left to be the width of our rectangle? That is 17. So our area of our rectangle here is going to be the 36 length times this 17 width here. So what about our area of our parallelogram? Once again, we don't know if this is an area of our square, because this doesn't mean that this is going to be, so we're going to treat it like an area of a parallelogram. So we know that this side, this height is 11. So we got to figure out what our base is, but we know our height is 11. And we can find out what our base is because we know this total length is 36, but we know this little piece here is 22. So this is going to be the difference of 36 and 22. So what's the difference of 36 and 22? 14. So you see, this is actually a rectangle. It's not a square like this one was. So when we multiply all of these, we get 612 and 154. So when we add all of these together, we get 766. So this is our area of our outside. 766 meters squared. So we found the area of our inside and our outside. Now we have to subtract the sum of our inside from our outside. However, this was just one shape, so there really is no sum to add here. We're just going to take the total area of our inside shape and subtract it from the total area of our outside shape. So the area of our outside is 766. The area of our inside is 157. And when we subtract both of those, we get 609. But don't forget, you have to put your meters squared. So now we have our area of our shaded region. So I'm going to say this is the area of the shaded region. So A shaded is 609 meters squared. So I hope you're able to follow our steps in our example, and I hope you found the time codes helpful. If you have any question about what you saw here today, or even your own homework, remember you can put them in the comment box below, or visit me on Facebook at Tutor Me Sempai and tell me all about it there. If you haven't done so already, remember to leave a like, hit the notification bell, smash the subscribe button, and share this video with a friend. Well, that's all the time I have for today. I'm really hoping this helped with your homework, and I'm looking forward to seeing you again next week. I'm Courtney, and this is another session of Tutor Me Sempai.